Engine. An inline engine is one of the most common engine layouts used in cars today. In this design, all the cylinders are arranged in a straight line, usually mounted vertically inside the engine bay. Because of its simple structure, the inline engine is relatively easy to manufacture and maintain. Smaller cars often use inline four-cylinder engines because they balance efficiency, reliability, and cost. This layout has been popular since the early days of automobiles and remains widely used for everyday passenger vehicles. A V engine arranges its cylinders in two separate rows that form a V shape when viewed from the front. This layout allows more cylinders to fit into a shorter space, which is why it is commonly used in larger and more powerful cars. V6 and V8 engines are especially well known for delivering strong performance and smooth power. Over time, this design became a favorite for sports cars, trucks, and luxury vehicles because it provides a good balance between size and power output. A flat engine, sometimes called a horizontally opposed engine, places its cylinders on two sides lying flat and opposite each other. Instead of moving up and down in a vertical line, the pistons move outward from the center. This arrangement lowers the engine's center of gravity, which improves vehicle stability and handling. Because of this advantage, some car manufacturers have used flat engines in vehicles designed for better road balance and driving control. A rotary engine works in a completely different way compared to traditional piston engines. Instead of pistons moving up and down inside cylinders, a triangular rotor spins inside a specially shaped chamber to produce power. This design is compact and capable of producing high power from a small engine size. Although it is less common today, the rotary engine gained attention for its smooth operation and unique engineering concept. An electric motor powers vehicles using electricity stored in large battery packs instead of burning fuel. When electricity flows through the motor, it creates magnetic forces that spin the motor and move the car's wheels. Electric motors are quieter and produce no exhaust emissions, which has made them an important part of modern transportation. As battery technology improves, electric vehicles are becoming more common around the world. Engine. A hybrid engine combines a traditional gasoline engine with an electric motor. The system switches between the two or uses them together depending on driving conditions. During slow driving or city traffic, the electric motor may power the car, helping save fuel. On highways or during acceleration, the gasoline engine provides additional power. Hybrid technology became popular as car makers searched for ways to reduce fuel consumption and engine. A diesel engine is designed to run on diesel fuel and operates using high compression instead of spark plugs to ignite the fuel. This method allows diesel engines to produce strong torque and better fuel efficiency, especially for long-distance driving. Because of their durability and power, diesel engines have been widely used in trucks, buses, and some passenger vehicles for many decades. Engine. A turbocharged engine uses a device called a turbocharger to push extra air into the engine's combustion chamber. More air allows more fuel to burn, which increases the engine's power without making the engine itself much larger. This technology became popular as manufacturers looked for ways to make smaller engines more powerful while still improving fuel efficiency. Many modern cars now use turbocharged engines for this reason. Engine. A supercharged engine also increases power by forcing more air into the engine, but it does this using a compressor driving directly by the engine itself. Because the supercharger is mechanically connected, it can deliver extra power immediately when the driver accelerates. This type of engine has often been used in performance cars where instant response and strong acceleration are important. Cell engine generates electricity by combining hydrogen with oxygen inside a fuel cell system. Instead of burning fuel like a traditional engine, it produces electricity that powers an electric motor. The only byproduct of this process is water vapor. Although still developing, hydrogen fuel technology is seen as a possible future alternative for clean transportation.